Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing how to perform multiplication with polynomials. Previously, I showed you how to add and subtract with polynomials, and as I mentioned in that previous video, multiplication is a little bit more involved, and for that reason, I decided to make a separate video covering it. As always, there's going to be practice questions in this video. More specifically, they're going to be at the end of the video. So if you're good at math already, you can go ahead and jump ahead to the practice questions. If you work those out and you get them all right, chances are this is a topic that you're already pretty good at. Otherwise, I recommend you watch this video from start to finish. And as you can see, there are 6 topics in today's video. In order to multiply polynomials, you have to understand how to apply the product rule. After that, we're going to take a look at a few examples. Specifically, we're going to look at how we can multiply a monomial by a monomial. Then we're going to look at multiplying a monomial by a binomial or trinomial. After that, we're going to look at multiplying a binomial by a binomial. And then finally, we're going to look at multiplying a binomial by a trinomial. Let me stress this. Once you get to the practice questions, that's when you want to pause the video, attempt to work out the questions on your own, and then resume playing the video to check your solution. So with all that being said, let's go ahead and get started with today's video. All right, so as I just mentioned, you have to understand the product rule, which is one of the laws of exponents, in order to multiply polynomials. So to start this video, let's go ahead and quickly review how to do that. Again, the product rule says this: to multiply two exponents with the same base, you keep the base the same and then you add the powers. So here you can see we have base A raised to the n power, base A raised to the n power. When we multiply those, since they have the same bases, we keep the base the same and we just add the powers. So let's go ahead and get some practice doing that before we move on to multiplying polynomials. And at this point in the video, if you want to pause the video and attempt to work these out on your own, I'd encourage you to do so. Otherwise, you're more than welcome to just follow along. So this first question says x times x to the fifth. Well, I'm going to write this off to the side over here. Again, we have x times x to the fifth. In order to apply the product rule, we have to have the same bases. And in this case, we have a base of x here and a base of x here. So we can apply the product rule here. That said, it may not be obvious that this x right here is raised to the first power. Again, when anything's raised to the first power, it's not going to be expressed. But that said, if you're working this out, you can simply add that 1 there. And then, according to the product rule, this is simply going to become x to the 1 plus 5, which is the same as x to the 6th. Let me go ahead and put a box around that to indicate that this one is done. All right, let's take a look at example 2 now. In this case, we have y to the third times y to the fifth. So we have y to the third times y to the fifth. Again, in order to apply the product rule, we have to ensure that the bases are the same. In this case, we have base y raised to the third power and base y raised to the fifth power. Since the bases are the same, we know our answer is going to look like this. We're going to keep a base of y, and then we're simply going to add the exponents together. So this is going to become 3 plus 5. And of course, 3 plus 5 is just 8. So in other words, y to the third times y to the fifth is y to the eighth. All right, let's go ahead and take a look at number 3 now. I'm simply going to start by copying it off to the side here. So we have y to the fifth times x to the fifth. And in this case, we cannot use the product rule to combine the exponents because they don't have the same basis. Again, in order to apply the product rule, you have to have the same basis. Remember, the product rule was a to the m times a to the n results in a to the m plus n. Again, look, the bases are both a. In this case, we have a base of y and a base of x, so we can't combine their exponents. That said, we can rewrite this as this, x to the fifth times y to the fifth. That is to say, we can actually get rid of this multiplication sign just by combining these like this. All right, so that's that one, and let me put a box around it to indicate that we're done with it. And finally, we have x squared y times x, y to the seventh. So let's go ahead and copy this one off to the side. We have x squared y times x, y to the seventh. All right, so if it's helpful, wherever you don't see an exponent, you can fill in a 1 accordingly. And now we're going to apply the product rule, but we can only, again, apply the product rule to the variables that have the same bases. So first, I'm going to apply the product rule with these x's. So this becomes x. And again, we're simply going to add their exponents. So this is going to become x, 2 plus 1. And then likewise, we're going to use the product rule to combine the exponents for the variables that have the base of y. So this becomes y 1 plus 7. And let's go ahead and do that simple arithmetic there. This becomes x to the third times y to the eighth. All right, so as you're going to see in just a few minutes, many of the questions we're going to work with are going to be jumbled up like this. So again, just remember that according to the product rule, you can only add exponents if the bases are the same. All right, so with that in mind, let's go ahead and take a look at our first case of multiplication of polynomials. All right, so now that we've reviewed the product rule, let's take a look at a few examples involving the multiplication of polynomials. To start, let's look at the most basic instance of that. Notably, let's look at what happens when we multiply a monomial times a monomial. And in case you forgot, a monomial is simply a polynomial that only has one term. And if you look right here, this is one term and this is another term. So we're taking this monomial and multiplying it by that monomial. And I did define that in yesterday's video, so if you want to go back and watch that, that'd be a good idea. But that said, as far as multiplying monomials together goes, it says to multiply a monomial times a monomial, just multiply the coefficients, that is the whole numbers, and then multiply the variables using the product rule. So let's go ahead and write this one off to the side. As you can see, we have negative 2x squared y. And instead of using parentheses, I'm just going to put the multiplication symbol there, times x, y to the seventh. All right, so the first step is to take care of our coefficients. So our coefficients are the whole numbers. We have a coefficient of negative 2 here. That said, what's the coefficient in front of x here? Well, whenever the coefficient's not expressed, it's implied that it's a 1. And likewise, we can go ahead and add our implied 1 exponents as well. So again, there's no exponent on top of this y, so let's put a 1 there. And there's no exponent above this x, so it's implied that it's a 1. All right, so let's take care of the coefficients. This becomes negative 2 times positive 1. Negative times a positive is going to be a negative, so this is just negative 2. And now using the product rule, let's go ahead and take care of our variables. This says x squared times x to the 1. Again, according to the product rule, we keep our base the same, and then we add the exponents. So this becomes x to the 2 plus 1. Let's do the same thing here for y. Keep y the same, and then add the exponents. Again, this says y to the first times y to the seventh. According to the product rule, that becomes 1 plus 7. Let's go ahead and do this simple arithmetic to clean this up a little bit. We have negative 2x. 2 plus 1 is 3. And then y. 1 plus 7 is 8. All right, that's all there is to multiplying a monomial by a monomial. All right, so now that we've seen that, let's go ahead and work on another instance involving the multiplication of polynomials. And in this case, we're going to look at what happens when we multiply a monomial times a binomial or trinomial. Again, as we know, a monomial is a one-term polynomial, whereas a binomial is a two-term polynomial, and a trinomial is a three-term polynomial. And if you like following instructions, I went ahead and wrote out some simple instructions for you here. It says simply use the distributive property and multiply a monomial times the binomial or trinomial, and then use the product rule to simplify the expression accordingly. Let me just point this out. In this case, the term that's outside the parentheses is a monomial since there's only one term, whereas what's inside the parentheses is a trinomial since there are three terms. Again, there's one here, and one here. So let me start this one by writing it off to the side. We have negative 2x times x squared plus 3x minus 8. All right, so if it's helpful, you can go ahead and wherever there's not an exponent on a variable, you can place a 1 since it's implied. And now that we've done that, we can go ahead and take this negative 2x and distribute it here, here, and here. So let's go ahead and see what that looks like. And again, if you recall, when we multiplied a monomial by a monomial, it said multiply the coefficients first. Well, if there's no coefficient, that means it's implied that there's a 1 coefficient there. So let's go ahead and expand this. We have negative 2x to the first times 1x squared minus 2x to the first times 3x to the first. And then finally, we have negative 2x to the first times negative 8. All right, now that this is expanded via the distributive property, let's go ahead and use the product rule accordingly to simplify this expression. So here we're just going to multiply the coefficients first, notably negative 2 and positive 1. Negative 2 times positive 1 is going to be negative 2. And then we're going to use the product rule to add these exponents. So this becomes x to the 1 plus 2. Right here, we're going to multiply our coefficients, notably negative 2 and 3. Negative 2 times positive 3 is going to be negative 6. And then let's use the product rule to deal with these exponents. Again, we're just going to have x to the 1 plus 1 here. And then let's do this final one now. Again, multiply the coefficients first, notably negative 2 and negative 8. A negative times a negative is going to be a positive. So this is going to become positive 16. There's nothing to multiply this x by, so this just becomes x to the 1. And now let's take care of these basic arithmetic here. So this becomes negative 2x. 1 plus 2 is 3 minus 6x. 1 plus 1 is 2 plus 16. Again, you don't express that 1, so we'll just leave this as 16x. And just like that, we multiplied this monomial by this trinomial. All right, so ultimately, and this is the reason I include a lot of practice questions in my video, ultimately, your goal is to be able to go from here right to your answer. Again, that's going to take a little bit of practice, but generally, once you get good at multiplying polynomials, you can look at one and go straight to the answer without having to write out these superfluous steps here. So that said, let's go ahead and take a look at another example. All right, so in this example, we're going to be multiplying a binomial by a binomial, that is a two-term polynomial by a two-term polynomial. And if you like instructions, here they are. It says to multiply two binomials, use the distributive property or the FOIL method. And the FOIL method stands for first times first, outside times outside, inside times inside, and last times last. Once you do that, you're going to use the product rule to simplify the expression accordingly. Let me say this. I'm not a big fan of the FOIL method because, again, you're just using the distributive property. The FOIL method is just a name for the distributive property. So let's go ahead and get started with this one. In this case, we have x plus 2 times x minus 3. And if it's helpful, you can go ahead and express the ones as your powers where it's not present. Again, you don't have to do that. But that said, if you haven't done this in a while, it might be helpful. This is x to the 1, x to the 1. And again, we're going to use the distributive property to expand this. And what that means is, to start, we're going to take this first term, x, and we're going to distribute it here and here. And then we're going to take this second term, 2, and we're going to distribute it here as well as here. All right, so let's go ahead and get started doing that. So again, first we have x to the first times x to the first, so that becomes x to the first times x to the first. And then we had plus x to the first times negative 3. After that, we moved to this 2, and then we had plus 2 times x to the first, and then we had plus 2 times negative 3. All right, let's go ahead and use the product rule to simplify this expression accordingly. So right here, we can use the product rule to make this x to the 1 plus 1. And then right here, we have x to the first times negative 3. So we're not going to use the product rule. Instead, we're just going to write this like this. Minus 3x to the first. And then right here, we have 2 times x to the first. So there's nothing we can do there as far as the product rule goes. That said, we're going to simplify this by dropping the multiplication sign such that this becomes plus 2x to the first. And then at the end here, we just have positive 2 times negative 3, which is negative 6. All right, let's go ahead and work on simplifying this. So x to the 1 plus 1 is x squared. And let's go ahead and not express this 1. So this is going to become negative 3x plus 2x minus 6. Well, if you watched my video yesterday, you would know that negative 3x and 2x are like terms. Therefore, we can combine them. So this simplifies to x squared. Negative 3x plus 2x is just negative x minus 6. All right, and we are done with that one. All right, so let me just stress this again. Many of you can probably go from here right to here. Again, if you could go from here right to here, this video is probably not for you. I'm working out these 2 steps here because a lot of people haven't worked with polynomials in a very long time, and they have to see those implied ones expressed in order for them to be able to apply the product rule and ultimately simplify the expression. So that's the reason I'm working it out like this. Once we get to the practice questions in this video, chances are I'm going to show fewer of these steps and start forcing people to go right to this step right here. All right, so with that said, let's take a look at our 4th and final example. All right, so in this last example, we're going to look at multiplying a binomial by a trinomial. And let's take a look at our instructions here. It says to multiply 2 polynomials where at least one has more than 2 terms. Distribute each term in the first polynomial to each term in the second polynomial, use the product rule to simplify the expression accordingly. And here's why I don't like the FOIL method. Again, the FOIL method just means distribute, which just means take the first term, multiply it by everything in the second polynomial, take the second term, and multiply it by everything in the other polynomial. So let's go ahead and see what that looks like. Not surprisingly, I'm going to start by copying this one down. We have 2x minus 3, and then we have x squared minus x plus 1. Again, we're going to use the distributive property to work this one out. And this is the last time I'm going to do this in the video. If it's helpful, you can go ahead and express those exponents of 1. So we'll have an exponent of 1 here and an exponent of 1 here. And again, according to the distributive property, we're going to take this first term, notably 2x, and we're going to multiply it here, here, and finally here. That is to say, we're going to take the first term and multiply it by all the terms in the second polynomial. And then we're going to take this second term, negative 3, and we're going to do the same thing. That is to say, we're going to multiply it here, here, and then here as well. So let's go ahead and work this out. All right, so as you can see, the first thing we're going to do is 2x to the first times x squared. That's right here. Then we're going to do plus 2x to the first times negative x to the first. Then we're going to do plus 2x to the first times 1. All right, so we took this first term and multiplied it by all these terms. Now we're going to move on to this negative 3, and this is going to become minus 3 times x squared minus 3 times, and let me put that multiplication symbol in there for you, times negative x to the first, and then finally we have negative 3 times 1. So let's go ahead and apply the product rule to simplify this one. Again, if it's helpful, you can imagine there's coefficient of 1 there. So we have 2 times 1, which is 2. And then we take the exponents and add them. So this becomes x1 plus 2 plus. Again, if it's helpful, you can express 1 there. This is positive 2 times negative 1. So let's get rid of that plus symbol. Because again, positive 2 times negative 1 is going to be negative 2. And then let's add the exponents, x1 plus 1. Let's work this one out here. This is just 2x to the first times 1. Anything times 1 is just itself. So this becomes just plus 2x to the first. Let's work on this right here. So this is minus 3x squared. And let's go ahead and work on this. That's a negative sign. This is negative times negative. Negative times a negative is a positive. So this is plus 3x to the first. And then finally, we have a negative times a positive. So this is negative 3. Let's go ahead and simplify our exponents even more. 2x to the 1 plus 2 is just 2x to the 3 minus 2, x to the 1 plus 1 is 2, plus 2, and I'm going to get rid of this implied 1 such that it's just 2x, and then we have minus 3x squared plus 3x, again, get rid of that 1, minus 3. We're not done with this one in as much as we have to combine like terms now. And like terms have the same letter variable raised to the same power. So this negative 2x squared has the letter variable x raised to the second power. So we're going to combine it with this negative 3x squared. So this becomes 2x to the third. Let's go ahead and combine these two. Negative 2x squared plus negative 3x squared is negative 5x squared. Now that we've combined them, we can cross them out. All right, And we also have like terms here, 2x and 3x becomes plus 5x and then minus 3. All right, so we are done with that one. Again, with practice, you should be able to go from this right to here, and then simplifying it should be pretty simple and straightforward. That said, if you need to express those implied ones to get the hang of this, by all means do so. But otherwise, the goal is to go from here to here to here. So all right, so with that said, let's go ahead and take a look at a few ASVAB practice questions. Again, these could mirror what you'll see on the ASVAB. So at this point in the video, what you want to do is pause the video after read a question, work out the question on your own, and then resume playing the video to check your solution. Again, I'm not going to be expressing those applied ones because the goal is to get you from going from that first step to almost the last step without too much effort. So again, there's 10 of these. Should take you about 15 minutes or less to get through them. All right, this first question says 8x to the third y squared times negative 3x squared y to the third. So we're multiplying a monomial by a monomial. And so if you remember our steps accordingly, we're going to take our coefficients, notably 8 and negative 3, and multiply those together. Positive times a negative is a negative, so we know this is going to be negative. 8 times 3 is 24. All right, now that we've taken care of our coefficients, let's go ahead and take care of our exponents using the product rule. Here we have x to the third times x squared. According to the product rule, we're just going to add those exponents together. So this becomes x to the 3 plus 2. And then finally, we have y squared times y to the third. Again, according to the product rule, we just add those exponents. So this becomes 2 plus 3. And let's go ahead and simplify this a little bit further. This is negative 24 x to the fifth y to the fifth. And let me box that to indicate I'm done with that one, but nothing too difficult there. Number 2 says negative x to the third y times negative 8x squared y to the third. Again, there's an imaginary 1 here, and there's an imaginary 1 here. I'm not going to express it. Again, you want to get away from using those imaginary ones and just work out the problem accordingly. So let's get started here. So we have negative 1, imaginary 1, times negative 8. Well, a negative times a negative is going to be a positive, and negative 1 times negative 8 is going to be positive 8, so our coefficients are done there. Now we're going to use the product rule to take care of our exponents. So we're going to look at our x's now. This is x to the third times x squared. Again, according to the product rule, we just add those exponents. So this becomes 3 plus 2. And now let's take care of our y's. Again, there's an implied 1 here. So this is y to the first times y to the third. According to the product rule, we're just going to add those. So this will be 1 plus 3. Let's go ahead and simplify this a little bit further. So this becomes 8 x to the fifth y to the fourth. And let's put a box around that one since we're done with it. All right, so let's look at this next one, and I'm going to write it off to the side in case that's hard to see. We have j squared times k to the fifth, j to the third. All right, so let's simplify this one. Again, we can't really do anything with this j and this k, but that said, we can use the product rule with j squared and j to the third. So this is going to become k to the fifth, j, and then this is j squared times j to the third. According to the product rule, that becomes 2 plus 3. So this simply reduces to k to the 5th, j to the 5th. And we are done with that one. All right, let's take a look at number 4 now. We have 2x to the 3rd times x squared plus y in parentheses. So let me copy this one down to the off to the side. We have 2x to the 3rd x squared plus y. Again, we're going to have to use the distributive property to work this one out. That is to say, we're going to take this 2x, we're going to multiply it to this term, and then after we do that, we're going to have to multiply it to this term. So let's go ahead and do that. Again, if it's helpful, there's an imaginary 1 here. So this becomes 2x to the 3rd times x squared plus 2x to the 3rd times y. Let's clean this up a little bit. Again, first you look at your coefficients. This would be the same as 2 times 1. 2 times 1 is just 2, so this becomes 2x. According to the product rule, we can go ahead and add these exponents, so this is going to become 3 plus 2, and then this is plus. And there's nothing to do here except for to get rid of this multiplication symbol by making this one term. So this becomes 2x to the 3rd y. Let's go ahead and work this out very quickly. This is 2x to the 5th plus 2x to the 3rd y. And just like that, this one is done. All right, let's move on to number 5 now. We're halfway done with this one. And for this one, we have m squared times 3m to the 3rd plus m squared minus m plus 6. So I'm going to copy this one down right here. So in case you're using your cell phone to watch this video, you can actually see it. So we have m squared 3m to the 3rd plus m squared minus m plus 6. Again, we're going to use the distributive property to take care of this one. More specifically, we're going to take this m squared and we're going to distribute it to every term inside the parentheses. So we're going to take it. We're going to multiply it here, 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 and finally here. It's kind of a tedious problem. But that said, you will see stuff like this on the ASVAB, so better practice for it now than be caught flat-footed on test day. So again, the first thing we're going to do is m squared times 3m to the 3rd. Let me go ahead and express that over here. This becomes 3m to the 3rd times m squared. Then we have plus m squared times m squared plus m squared times negative m plus m squared times 6. All right, let's use the product rule to simplify this one accordingly. Right here, there's a coefficient of 1. So 3 times 1 would just be 3. So this is 3. And then according to the product rule, we can add these exponents. So this becomes m to the 3 plus 2 plus, again, we can use the product rule here. This will become m. Again, there's a 1 here and a 1 here. 1 times 1 is just 1. So that coefficient is just going to be 1. And then this is going to be 2 plus 2 according to the product rule. And let's go ahead and work on this. And let me get rid of that plus because, again, there's an imaginary plus 1 here and an imaginary negative 1 here. Positive 1 times negative 1 is going to be negative. So this is going to become negative m to the 2. And again, what's right here? Since it's not expressed, there's a 1 right there. So that becomes negative m to the 2 plus 1. And then finally, we have this. 6 times m squared. No product rule to use, but we can get rid of this multiplication sign. More specifically, we can write this as 6m squared. All right, let's go ahead and simplify this now. So we have 3m to the 5th plus m to the 4th minus m to the 3rd plus 6m squared. And you should notice this. When you're expressing these polynomials, you write them such that the terms with the highest powers come first. So here we have a power of 5. You write that before any other power, and then we have 4, 3, 2. So again, when you write these polynomials, the highest order powers come first, and you can see that that is the case in this one. We go 5, 4, 3, 2. All right, let's look at number 6 now. Number 6 is a little bit challenging, but the same idea. We have negative x squared y times x squared plus 7xy minus 6y to the 3rd. Again, we're going to use the distributive property first, which means we're going to take this first term and distribute it to everything inside parentheses. So we're going to take it and distribute it here, here, and finally here. So let's go ahead and work on doing that. Again, I'm not going to express those implied ones. But that said, as you can see, the first thing we're doing is we're taking negative x squared y, and we're multiplying it by x squared. After that, we're taking negative x squared y, and we're multiplying it by 7xy. And then finally, we're taking negative x squared y, and we're multiplying it by negative 6y to the 3rd. Let's go ahead and clean this up by taking care of our exponents as well as our coefficients. So again, technically there's a 1 here and a 1 here. Negative 1 times negative 1 times positive 1 would be negative 1. So we're just going to leave this as negative x. But that said, according to the product rule, we can add these two exponents such that they become 2 plus 2. Nothing to multiply y by, so we'll just leave that as is. Again, technically there's a 1 here, so this would be negative 1 times positive 7. So that's going to become negative 7. Let's take care of the exponents now, starting with the x's. This becomes x to the 2 plus 1. Again, that 1's implied there. And then we have y, and then this is 1 and 1, so that's 1 plus 1. Let's take care of this right here. We have negative x squared y times negative 6y to the 3rd. Again, technically there's a 1 here, so we have negative 1 times negative 6, and negative times a negative is a positive. So this becomes plus 6. And let's take care of the exponents now. There's nothing to multiply this x by, so this is just x squared. That said, we can apply that product rule here. So this becomes y to the 1 plus 3. Again, that 1's implied right there. Let's go ahead and clean this up now. This becomes negative x to the 4th y minus 7x to the 3rd y squared plus 6x squared y to the 4th. All right, so that is that one. And let's go ahead and move on to the next one now. Thankfully, the next few are a little bit simpler. And as you can see, we're multiplying a binomial by a binomial. So we're going to take this first term, multiply it by both of these terms. Then we're going to take this second term and multiply it by both of these terms. That's also called the FOIL method, if that's how you learn how to do that. That said, let's write this one off to the side. We have x plus 6 and x plus 2. All right, so again, we're going to use the distributive property to expand this one. So we're going to take this first term and multiply it by both of these terms. Then we're going to take this second term and multiply it by both of these terms. So let's work this out. This becomes x times x, and then x times 2. So plus x times 2. Now we're on to the 6. This becomes plus 6 times x plus 6 times 2. All right, let's go ahead and simplify this using the product rule where applicable. So again, imagine there's these ones here. This becomes x to the 1 plus 1. This just becomes x times 2, which is the same thing as 2x. This becomes 6 times x, which is the same thing as 6x. And then this is just 6 times 2, which is 12. All right, let's clean this up now. This is x squared. And 2x and 6x are like terms, so we can add them. So this becomes 8x plus 12. All right, so that's that one. And again, you could have pretty much gone right from this to this. And if you keep practicing, you will be able to go from this right to your answer for these. So as we can see, number 8 says 3x plus y squared. Let's rewrite this so it's a little bit easier to work with. 3x plus y squared is the same thing as this. 3x plus y times 3x plus y. And here you can either use the FOIL method or simply distributive property to expand this accordingly. Again, I like the distributive property, which means you're going to take this first term and multiply it by everything in the second set of parentheses. So you're going to multiply it here and here. Then you're going to take this second term and multiply it here as well as here. So let's go ahead and do that. As you can see, we have 3x times 3x. And then after that, we have plus 3x times y. And then we're going to move on to our y, so this becomes plus y times 3x. And then finally, we have just y times y. So let's go ahead and start simplifying this. Again, multiply your coefficients here. So this becomes 3 times 3, which is 9. Again, there are implied ones here, so we can use the product rule. This becomes x to the 1 plus 1. 3x times y is just the same thing as 3xy. And that's all we have here. We have y times 3x, so this just becomes 3xy. And then here we can apply the product rule since there are implied ones there, so this becomes y to the 1 plus 1. Let's go ahead and clean this up. So this becomes 9x squared. 3xy and 3xy are like terms, so this becomes plus 6xy, and then plus y, 1 plus 1, so that's y squared. And just like that, we are done with this one. All right, 2 more to go. Let's go ahead and take care of them. For number 9, it says x minus 2 times x squared minus x plus 3. So we're going to take both terms in this first set of parentheses and distribute it to all the terms in the second set of parentheses. So let's see what that looks like. Again, we have, and let me go down a line here. We have x minus 2 times x squared minus x plus 3. All right, so we're going to take this x and distribute it here, here, and here. And we're going to take this -2 and distribute it here, here, and here. Let's go ahead and work on doing that. Again, to start, we have x times x squared. So that's, again, x times x squared. Then we have x times -x. So this is plus x times -x. Then we have x times 3. So this is plus x times 3. And then we're moving on to our -2. So we have -2 times x squared. And then we have -2 times -x. And then finally, we have -2 times +3. Let's go ahead and simplify this now. Again, we can use the product rule here. So this becomes x to the 1 plus 2. And then we can use the product rule here. But that said, we have an implied 1 here. So this is 1 times -1. So this is going to be negative. And then this is just x 1 plus 1. Right here, we just have x times 3, which is just 3x. So this is plus 3x. Right here, we have -2 times x squared. So that's -2x squared. Right here, we have -2 times -x. Negative times a negative is a positive. So that's going to be plus 2x. And then finally, we have -2 times +3. A negative times a positive is a negative. So that's going to be -6. All right, let's go ahead and keep cleaning this up. So we have x to the 3rd minus x squared plus 3x minus 2x squared plus 2x minus 6. Let's combine like terms. X to the 3rd doesn't have anything we can combine it with. But that said, this -x squared can be combined with this -2x squared to become -3x squared. Again, yesterday I uploaded a video regarding adding polynomials. So if you need to watch that, you can go ahead and do so. So we've taken care of that. Let's just go ahead and put a line through it to indicate that we've done so. Then we have 3x and 2x, which are like terms, so we can go ahead and add those such that it becomes plus 5x. And then we just have minus 6. And as you can see, we express this one such that the highest order polynomial comes first, followed by the next exponent next, and so on and so forth. So that's that one. All right, so for number 10, I'm not going to work everything out. I'm just going to go pretty much straight to the answer to show you that you can get good enough at these such that these problems are very easy. So that said, I will write it out. So if you're viewing this on a mobile device, you can see the question better. Again, we have 2x minus 5, and my pen is starting to act up here, times 5x squared plus 4x plus 7. Again, we're going to use the distributive property, which means we're going to take this first term and multiply it by all these terms. And we're going to come back and take this second term and multiply it by all these terms. I know I've been drawing lines in an effort to show you how to do that, but again, I'm working this one out as if I was taking the test. So to start, I got 2x times 5x squared. So I know that's going to be 10 for my coefficient. And then x to the 1 times x squared is going to be x to the 3rd. Let's move on. We have 2x times 4x. So that's going to become plus 8x squared. And then we have 2x times 7. So that's going to become 14x. My pen is starting to run out of battery here, so bear with me. So I just did 2x times all these terms. Let's go back and work on this -5 now. So we're going to multiply coefficients of -5 and +5. So that's going to be minus 25x squared. And then we have -5 times +4, which is negative 20. And there's nothing to do with the x's there except to tack it on. And then we have negative 5 and positive 7, which is negative 35. Let's go ahead and see if we got some like terms we can combine. We have 10 x to the third. Nothing to combine that with. That said, we have 8x squared and negative 25x squared. So that's the same thing as 25 minus 8, which is going to be 5 minus 8. We can't do. We have to borrow. This becomes 1. This becomes 15. 15 minus 8 is 7, and 1 minus nothing is 1. So this is not plus. And let me get my eraser here. This is not plus. This is minus 17x squared. Again, I just took this 8x squared and combined it with this negative 25x squared, which is negative 17x squared. And then I have this 14x and this negative 20x, which is going to be negative 6x when you combine them, minus 35. All right, and I'm done. Again, this is a pretty complicated problem, but that said, once you get very good at working out these problems, you no longer have to draw those lines like that. And what's more, you can multiply the coefficients in your head, and you can add the exponents in your head. But at the same time, you're still going to have to go through your expression and combine like terms. If you can combine like terms in your head on the fly, then you're probably a genius. But that said, I just wanted to show you how you can solve these without having to go through all those baby steps. It's quite possible. In fact, a lot of people are capable of doing it. So you want to work to where you get to that point. That said, if you still have to write in those imaginary ones and so on and so forth, go ahead and do so. But that said, that is it for this video. I hope you found it helpful. Admittedly, covered a lot of material in this video, and I hope I did so in a way that makes it clearer to you than it would otherwise be. If you like the content I'm creating, please consider subscribing to my channel. In addition, you're more than welcome to leave feedback in the comment section below. But on that note, I'm going to go ahead and cut you loose.